which is our 6G flagship project that we work with all sorts of partners. And I'm here with Simon, who is going to be talking about Reason and showing us the demos. We're very tired, so please bear with us. We've been walking and talking for like 3 days, so our brains might be a little bit slow. Also, we had an awesome party yesterday, which contributes to that.
I'm not even getting into that. I barely remember it. Yeah, good morning everybody. My name is Simon Saunders and I'm an honorary professor at the University of Bristol, which, as Maria was saying, we're the lead institution in this project, Reason 6G, which is funded by the UK government through the Department of Science, Innovation and Technology. And this stand is the outcome of nearly 2 years of work now, working with a bunch of partners from great companies like BT, the BBC, smaller companies like Viva Labs, and some others, and a whole bunch of universities, including yourself at Bristol. We've come together to really set the shape of future networks in the 6G era, set out the architecture that we think will deliver on the benefits of that. And it's not just mobile phones, it's a whole range of things. So we're looking at technologies from 5G to 6G, to Wi-Fi, to Li-Fi, which is communication over light. And the really big challenge that we're facing is how do you bring all that together and make it work nicely together. And what we've got around the stand here at the moment to show you is some demonstrations of things that you might want to do in that future networking world and how our underlying architecture will make those things possible.
The other thing that is really exciting about Reason is the introduction of AI into the architecture. Can you explain a little bit? Because our audience is really excited about AI, and I think everyone here is really excited about AI. And most of these things wouldn't be possible without it, right?
That's
So
absolutely right.
how are we using AI in this 6G architecture to make this happen?
No, exactly. AI is the magic fairy dust everywhere here. But we've worked out that you can take AI and you can apply it to an existing system and you can get some benefits from that. But what we really need for networks in the future is they're actually composed with AI, they are native AI within them, and that we have standard ways of moving attributes about the network that the AI can access and be trained on and learn from across different networks and different environments. So that's very much what we're doing here. Maybe we can bring that to life with this first demo.
Yeah, we tend to see that the screen is not working
That's
anymore,
great.
so
That's
I don't know.
We'll go to this one
Who's
first
in charge
instead.
of this demo,
This
guys?
one. This one's
Can
also
come
good
and
for
help
doing
us?
AI.
Yeah, we
Okay,
can.
let's wander through here. So let me tell you a word or two about this demo here.
Let's go to this one.
So one of the things that we want to do in the future world is to bring real world content to people in remote places, and we're not content with just a little 2D video. We want a real sense of presence and 3 dimensions to come together. So what we actually have here is a system for capturing a volumetric 3D avatar of a full-size person, and we do that using 48 really high-resolution video cameras. And I'm going to ask Maria to step inside the booth.
Oh my god, I'm gonna get my hologram!
Can I ask you to hold your microphone probably closer, because apparently the noise is a bit. Yes.
Okay.
Yeah.
And I'm going to ask our colleague Vasilis over there
Yes.
to start capturing a hologram of Maria. There's Vasilis going into action.
Fantastic.
Now,
Just
I'm
Yes.
gonna
step
step
onto the red cross there, Maria. Now let me explain a little bit while that's
Can you
happening.
hold your microphone closer?
Absolutely.
Apparently
I'm
it's
going
a
to pick
bit.
up my microphone
It's a
and
bit
down this, get a
noisy.
bit
Yes, yes.
There we go. So what's happening is 48 video cameras are taking a whole bunch of different angle shots of Maria. Each pair of video cameras, maybe we could take a look at this box here. We've got a camera here and a camera here, and they both go to this box, and this box processes video images, compresses them, and sends them over the air, because this is a wireless capture. And then if you point the camera to that little corner over there, and to these access points at the top, what you'll see is we've got not one but 3 different access networks simultaneously soaking up that video data. So there's a private 5G network at the top, there's a Wi-Fi 7 network at the bottom, and sitting next to that lens is a Li-Fi system using light. And what we need is a huge amount of data, starts at many tens of gigabits per second, to find its way back to our server to process this image. And that's a real challenge. That's more data than 5G can possibly handle on its own. On the other hand, Wi-Fi can handle a high data rate, but you're never sure what's happening. This is a really busy environment, so you never know who's on the Wi-Fi channel. So somehow we need to orchestrate to make all those things work nicely together. So the key sort of networking magic technology behind that is a thing called Matrix. Now some of you out there may have heard of that. The RIC, in a 5G, 4G Open RAN context, you have a radio intelligent controller. What we've got is the multi-access technology, radio intelligent controller, or Matrix, that works out how to combine those different access technologies together to deliver the best outcome, whatever the state of the underlying pieces is. So we get, even in this busy environment, very reliable and instantaneous transfer of that huge amount of data over here. Now, if we wander over there, a virtual Maria will have been appearing. This is using the Gaussian splitting, where all of those images are combined together, and we train many times a set of neural networks which are now representing Maria. So we've kind of captured Maria's very essence in the machine.
I can go into the metaverse now.
That's
I have
it.
my own avatar.
As a real person, you can retire and just send your avatar out.
I have my hologram now,
So
which is very cool.
Exactly. So that hologram has been composed of a bunch of neural networks that are recreating a volumetric version of Maria, so we can look at it in any angle. It's actually a video, so we can animate Maria too and make her do all sorts of things she may not want to do. And we've Gaussian splatted her into a virtual environment, which is actually the Guildhall in Bath in the UK. So she's in a very different place there. And it's not just a one-way deal where we just capture this nice image. What we're going to do in our festival, our Future Communications Festival on the 26th of March,